Okay, grade 8. Sorry I'm out again today, sick. I'm hoping you guys all weren't stunned yesterday and you guys were good for your substitute. The substitute had nothing bad to say about you guys, so I'm assuming today will be just the same. Your PR2 practice test on algebra. I'm going to go over all the questions. So as we do this, the substitute teacher might want to pause periodically to get you guys corrected if you need more time. Just raise your hand to let the substitute teacher know you need it paused, and you can take a little bit of time to copy things down. Correct your own work, and on Monday when I come back, if you have any questions, make sure you clarify anything that you didn't understand on Monday. So the first question says, in the equation, negative 2 equals 4x minus 1, an efficient way to isolate the variable is to add 2 to both sides. And the answer is false, because adding 2 to both sides, although it's not going to affect, if you add 2 to both sides, you can do that. The only problem is you have 0 equals 4x plus 1, and you really haven't worked towards isolating the variable. You still have a coefficient, and you still have a constant, and now you've actually made what was a 2-step equation into a 3-step, because now you're going to have to subtract 1 from both sides. You get negative 1 equals 4x, divide both sides by 4, and x would equal negative a quarter, or negative 0.25. So it's not, I guess the key word there is efficient, meaning the least number of steps. So the answer is false. You could do it, but why would you? What you probably should have done is added 1 to both sides, added 1 to both sides to start. In question 2, it says, in the equation negative 3x minus 2 equals 1, the second operation you should use is division. So let's just look at this equation, and I'm going to solve it using opposite operation. The first step I would do is add 2 to both sides to get rid of my constant. And once I get this, I'm going to divide both sides by the coefficient, giving an answer of x equals negative 1. So would I use division on my second step? Yes, I would, so therefore the answer is true. In question 3, when expanded using distributive property, the equation 3x minus 3 equals negative 12, the constant will be negative 3. Well, if I was to just look at this and say, what's the constant right now? There are some people that know the constant is the part of the equation that isn't attached to the variable, and they might say, yeah, that's what it is. But then it says when expanded. So what we're going to do here is we're really going to expand this. So we really have 3 groups of x minus 3, which would be 3x's, and 3 groups of minus 3 would be a total of negative 9. So the answer is false. The constant's really negative 9 when expanded. Okay, and sometimes we can see it when we draw it a little bit better. There's x minus 3. And if I multiply that by 3, I'd have 3 groups of x minus 3, which clearly shows the constant being minus 9. In question 4, the coefficient in the equation x over 2, and I said over 2 because I don't want to give it away, minus 3 is 4, and the answer is false. Although a 2 is attached to the x, the coefficient is really half. And the reason why is this is actually half of x, and half of x is half of, meaning multiplication x, or half of x. Or if I was to draw it, there's x, I would have half of x. So the coefficient's really a half, not 2. In the 5th question, it says solve using opposite operation, I believe. Let me just double check here. Yep, all of these are done using opposite operation. So we have a 1-step algebraic equation, and what we're going to do here is I have to realize that in order to isolate the variable, I have to do the opposite of what's there. And currently, this says I'm dividing x by negative 4, so the opposite would be to multiply both sides by negative 4. Whatever you do to one side, you make sure you do to the other in algebra, and you maintain equality, and you've solved it as x equals negative 4. Now, some of you know that once you get your answer, what you're supposed to do, and I'll use my white marker here, is take your x and substitute it for the value you found it and see if this is true. So if I look at this, negative 4 divided by negative 4 is going to be a positive 1 because a negative divided by negative is a positive. So it's true, negative 4 is x. In question 6, we have a 1-step algebraic equation again. We have negative 5x equals negative 10. This is multiplying the variable by x. So to get rid of that, I'm going to divide both sides, which is the opposite of multiplying, by negative 5. And I'm going to get x equals positive 2. If I substitute that into my original equation again, using my white marker, substitute a positive 2 right there, and 5 times 2 is negative 10. So the answer is true, x is 2. This is a pretty easy one. This is just a constant, but it's still a 1-step algebraic equation. 6 plus a number is equal to negative 2. Probably by inspection, this would be the easiest way to solve it, because I could actually say, okay, what number, 6 plus what number would be negative 2? And by inspection, I could say it's negative 8. But we'll go through the opposite operation procedure. To get rid of a positive 6, I will subtract 6 from both sides. And I'd have x does equal negative 8. 6 plus negative 8 is negative 2. Question 8, we start getting into two-step algebraic equations. And in the first one, we have negative 10x minus 2 equals 18. A little hard to solve by inspection when you have two steps. It is possible, but we're going to use opposite operation. Remember, when you have two-step algebraic equations, the easiest way to isolate the variable is to get rid of your constant first. And the constant's the part of your equation without the variable. So the minus 2 is my constant. The opposite would be to add 2 to both sides. I get negative 10x equals 18, and 2 would make 20, a positive 20. Divide both sides by negative 10. And I've isolated the variable, and I found that its solution is negative 2. If I go back in and substitute that, negative 10 times x minus 2 is positive 20 minus 2, which is 18. Question 9, we have a two-step algebraic equation. And actually, it's more of a grade 7 question than a grade 8. The only difference is, normally, in an equation like this, we have our coefficient variable and then we have our constant. Usually that's how we see it. But in this question 9, we actually put our constant first and our coefficient second. So we should all see that the 4 is your constant, and I'm going to subtract 4 from both sides to get rid of it. And I'm going to keep my positive sign there because it's kind of cute. And normally if it was negative, we would keep it as well. But I'm going to keep that positive sign. And the sum of 26 negatives and 4 more negatives is 30 total negatives. Divide both sides by 3, and x will equal negative 10. If I substitute it in, this will be 4 plus negative 30, which will be negative 26, which is what my value was up here. Question 10, the variance in this one is that my variable is not on the left-hand side, it's on the right, and my constant is first, and my coefficient is negative. So I have all of the different variances in one equation, number 10. So the first thing you're going to do to both sides is you're going to add 3 to get rid of your constant. And once you add 3 to both sides, you get rid of your constant. Now over here, a positive 3 and a negative 1 is going to leave you with a positive 2, or just a 2. I'm just going to leave it as a 2. A 2 on the left-hand side. And over here, you got to be careful, because what's left on this side is negative 2x. And sometimes people just think it's a take away 2x, but when you really take away 2x, it's the same thing as applying a negative 2x. It's the exact same concept. And sometimes it's easiest if we look at it from a modeling perspective, the negative 1 and negative 3. That would be negative 2x. So when I got rid of this 3 by applying 3 on both sides, I can clearly see that I have 2 negative x's left, not 2 positive x's. And once I know that, I'm going to divide both sides by my coefficient. And I'm going to get x equals negative 1. Okay, substitute back in to make sure it's correct. And negative 3, take away the product of those two. Take away the product of 2 and negative 1 would be a negative 2. And we have an integer question with subtraction. Now I know that if I keep flip changing, I get the same answer. And I do, I get negative 1. Question 11 is a two-step algebraic equation. This time we have a fractional coefficient. So we don't have all of x, we have a negative half of x. So the first thing I'm going to do is still get rid of my constant. It's always the most efficient way to do it. I'm going to have a negative half of x is equal to 11. And I know that to isolate it, if I double that, I would have a negative x. But I'm going to negatively double it by multiplying by negative 2. Opposite operation, I'm left with x. Whatever I do to one side, I must do the same to the other. I get x equals negative 22. Substitute it back into my original equation. I get 22 divided by 2 is 11. Negative divided by 11 is a positive. So 11 take away 1 is 10, which is what I have on my right-hand side. Question 12, we have a two-step algebraic equation again. This time our constant is first, and we have a negative tenth of x equals negative 1. So again, I acknowledge the 4 is my constant, so I know I want to get rid of that first by subtracting 4 from both sides. I have a negative tenth of x is equal to the sum of negative 1 and negative 4, which is negative 5. Multiply both sides by negative 10, and x will equal a positive 50. Go back and check my work. 4 plus a positive 50 divided by negative 10. 4 plus, I got to do division first, negative 5. The sum of those is negative 1, which is what I had on my right-hand side. Question 13. The variance is the variables on my right-hand side. My coefficient is first. And again, it's kind of a little tricky because it's not a positive x, half of x, it's a negative half of x. We're going to talk about that in a second. So the first thing I'm going to do is get rid of that positive 5. Some students think it's a negative 5, but it's a positive 5. If I was to draw it, I would have used 8 positives over here. I would have drawn something like this. So we can clearly see it's a positive 5, and I would apply negative 5 to create those 0 pairs. So I'm going to subtract 5 from both sides. An 8 and a negative 5 will make a 3. And then what I'm left with is this idea here, a take away half an x, or a negative half x. And remember, we said 1,000 times before, you can interpret it like this, or you can interpret it like this, or you can interpret it like this, or you can interpret it like this. It's up to you. But for our purposes, the easiest interpretation for isolating variables is probably that third one. And I'll show you why. So I'm going to write the negative half of x like this. And the reason why it's the easiest is because in one step, I can multiply both sides by negative 2, and I could find out the exact value of x without having to have a negative x. And x's value is negative 6. If I substitute that back into my original equation, a negative 6 divided by 2, I'd have 5 take away a negative 3, keep, flip, change, and I would have an 8. So it's true, x is negative 6. Question 14, we have distributive property. I don't think that's a negative. I'm just going to go check my work here. Yes, it is. It's a negative 4. So we have a negative 4 multiplied by x minus 5. So if I was to get rid of that negative sign, right, if I was just to get rid of it, I would have 4 groups of x minus 5, which would be 4x and would be a negative 20, because I'd have 4 x's and I have 4 negative 5s. The difficulty comes in the fact that I don't have 4 groups of it, I have negative 4 groups. And since I can't really model it, what I really want to think of it as being negative 4 times x, which would be negative 4x, and a negative 4 times a negative 5, which is a positive 20. Okay? So when I expand using distributive property, I would get that. And I could take away 20 from both sides to get rid of my constant, and I'd have negative 4x equals negative 40. Divide both sides by negative 4, and x would equal positive 10. If I substitute in here, I get 10 take away 5, which is 5, and a negative 4 times a positive 5, which is what this is a negative 20. Okay, so that's one way to solve it, using expansion. Now, I don't think it asked you for any particular way, so you could have solved it a different way. And what you could have done, if I group this here, you could have solved it by division first. So let's take this equation again, bring it over here. I'll bring my negative sign down with it. And this time I'm going to divide both sides by negative 4, because instead of having negative 4 groups of it, if I divide both sides by negative 4, I'm going to have just one group of it. And a negative 20 divided by negative 4 is a positive 5. Now I have a very simple algebraic equation, and x would equal positive 10. All right, our story problems. It says, Will orders a pizza pie from his favorite Greek restaurant, Pythagoras. Oh, how clever. The cost of the pizza is $7 plus $2 for each topping. How many toppings can he buy for $15? So the first part is define your variable. So 6, or x is going to equal how many toppings he can buy. I don't know how many he can buy. How many toppings? So then I'm going to say, okay, each topping costs $2, so I'm going to multiply the number of toppings by 2. And I don't need the dollar sign because we're doing algebra, so I'll just keep it as 2. So if I multiply how many toppings I buy by $2, that would tell me the cost of my toppings. But the pizza itself has to be $7, so I'm going to add 7 to it. And the total, or what it has to be equal to, is $15. Okay? Now, technically, this is probably an inequality equation, but we're using it as an equation. So I'm going to subtract 7 from both sides using my algebra. I get 2x equals 8. Divide both sides by 2, and x will equal 4. And if I go back to what I defined, therefore, will can buy 4 toppings. Okay? That's not so hard, is it? That's actually a grade 7 question, because remember, the grade 8 variances are negative coefficients and negative values in the other one. So if they were negative values or negative coefficients, then that would be a grade 8 question, but this is pretty straightforward. Question 16, if a side of a square was increased by 5 centimeters, the new perimeter is 52. What is the original side length? So the first thing you have to know is that a square has 4 sides of equal measure. Now hopefully you all knew that, S, 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 S. And the formula for the perimeter of a square is 4 multiplied by the side length. Because if the side length was 2, then 4 times 2 would give it a perimeter of 8. If the side length was 10, then 4 times 10 would give it a perimeter of 40. Okay? But for this one, the side length is increased by 5 centimeters. Okay? So if I increase the side length by 5, I'm going to have S plus 5 on all of them. Right? Because it was S, and then I'm going to increase it by 5 centimeters. So instead of being S, it's going to be S plus 5. The new, hang on a second, the new side length. So if I was to multiply the side length, it's no longer S, it's actually 4 multiplied by the new side length, which is S plus 5. So the new perimeter is 4 times the side length increased by 5, and that new perimeter is 52. So S is going to be the original side length. That's my first step. And S plus 5 is my new side length, and I know that if you have 4 of them, the new perimeter was 52. So now I'm going to use distributive property to isolate the variable. 4S plus 20 equals 52. Subtract 20 from both sides. 4S equals 32. Expand this page a bit. Divide both sides by 4, and S equals 8. Okay, so we go back. I now know the original side length was 8. So in the original square, it looks like this: 8, 8, 8, and 8, which means the perimeter of the original square was 32, and the perimeter of this new square was 52. Interesting. Question 17 says model and solve. Okay, so for this one we have a grade 7 question. There's nothing grade 8 about it, but it's modeling. So I have 4x's minus 3 equals positive 9. So what I'm going to do first is get rid of my constant by adding 3 to both sides. I'm going to be left with 4x over here equals, and I'm not even going to draw them again. I'm just going to go, that's 5, 9, 10, 11, 12. That's 12. And if 4x's have a weight of 12, then each x must have a weight of a quarter of that, which would be 3, and therefore x equals 3. In the second modeling, we have a distributive property. This is a grade 8 outcome. So we have 4 groups of x minus 3. So when we draw that, I have 1 group of x minus 3, and 2 groups of x minus 3, and 3 groups of x minus 3, and 4 groups of x minus 3. And that is equal to positive 12. So when I draw that, what I'm going to do to isolate it is I'm just going to think of this as being not 4 groups of x minus 3, but rather I can think of this as being 4x minus 12. It's very clear that that's 4x minus 12. So to isolate it, I'm going to add 12 to both sides. And when I do that, these all become 0 pairs. And I end up with a new equation of 4x equals, oh my gosh, I can't draw that, so it's 24 of them. And if 4x's have a weight of 24, then each x must have a weight of 6. So the answer is x equals 6. Question 19, model and solve. We have a fractional coefficient. It's the only difference here. So we have negative 1, minus 3, and a fifth of x. So that would be a fifth of x. First thing I'm going to do is add 3 to both sides. creates a zero pair. I have a fifth of x is equal to 2. And I'm going to multiply this side by 5. And when I do that, 5/5 of x will actually make a full x. And over here we have 10. So therefore, x equals a positive 10. And our last question is a modeling of distributive property one last time. It says two groups of 3x. Oh, what's going on here? Oh, hang on. So two groups of 3x minus 1 equals 10. So there's one group of 3x minus 1. There's two groups of 3x minus, oh, that's all I need is just two groups. So two groups of 3x minus 1 is equal to 10. So really, I can see this now as being 6x minus 2. That's what really two groups of 3x minus 1 is equal to. But when I have that, I'm going to get rid of my constant first by adding 2 to both sides. I get 6x is equal to 12. And if 6x is equal to 12, then each x must be equal to, how lazy is that? I just drew, instead of drawing two dots, I drew 1 positive times 2. So x equals 2. Okay, grade 8, that is the end of your tutorial video. Now, here's the deal. You have one class today, Friday, and Monday, I have you, what day is it? Day 6. I have you guys for a double, 8C, and a single for 8D. I'm planning on giving you your test on Monday. If you have any questions, make sure you email me or something if you have any questions, and I'll try my best to get back to you. But your test is on Monday.